Hello everyone, welcome to aplusbi. This channel is all about complex numbers, and in this video we're going to be solving a very nice exponential tower power equation. We have I to the power I equals e to the power I theta, and we're going to be solving for theta because everything else is a constant, right? So in another video, I think I talked about I to the power I. You can go ahead and check it out here, okay? Right here. Now, let's go ahead and take a look at this equation. So we're still going to go over the I to the I, but that's going to be a little fast. If you need more details, check out the video. So, first of all, I can go ahead and start with I. How do you write I in polar form? Since its argument, or the principal argument, is pi over 2, I can write it as e to the power I times pi over 2. Obviously, there are infinitely many values for this, or in infinitely many ways you can write it. We can also write it in the more general form as e to the power I times pi over 2 plus 2 pi n, where n is an integer. And this is going to give you infinitely many values because this is multi-valued. Make sense? Now, what is I to the I then, right? Well, we have an identity, which is z to the w is e to the power w ln z being the complex logarithm. We'll talk about that too. So I to the I is basically going to be e to the power I ln I. But the next thing we need to talk about is how do you find ln I, right? Well, here's how we can find it. ln I is the same as ln e to the power I times pi over 2, and that's just going to be I times pi over 2. Make sense? Easy, right? But again, I ignored the infinitely many values, the multi-valuedness of the function, just wrote the principal one. But you can just go ahead and add multiples of 2 pi. Okay? So it's going to look like this. E to the power I ln I is going to be e to the power I times, and ln I will be replaced with I times, normally pi over 2, but this time I'm going to write it as pi over 2 plus 2 pi n, where n is an integer again, right? We already talked about it. Where? Here. Okay. Now I times I is I squared. That's the funnest part of this, because that's a real number. So we're going to replace it with -1 and multiply this whole thing by pi over 2 plus 2 pi n. When we distribute the negative, we're going to get something like this: e to the power negative pi over 2 minus 2 pi n. But notice that this one, by the way, I disappeared, right? Negative n can be replaced with another integer like k, so this can be written as e to the power negative pi over 2 plus 2 pi k. That will be I to the I. You see, we're not even at I to the I to the I. But we're going to do that next. Let's go ahead and find out how we can do it. So I to the I to the I basically means this is my exponent, right? Otherwise, if you wanted to mean this one, this would be even easier. I to the I squared, and that would be I to the power -1, and that would be negative I. You see, that's a different story. So we use exponents in this order, and now I do know I to the I, so I can go ahead and plug it in here and see what happens, right? So, but before that, we can also do this. Before I replace I to the I with that, I could probably use the same identity that I used before, which is e to the power I to the I times ln I. Now I know both of these, right? We did ln I before, and we know I to the I. So now, this is going to be e to the power I to the I, which is e to the power negative pi over 2 plus 2 pi k, where k is an integer, remember that, right? This is I to the I. That's going to be multiplied by ln I, and ln I is I pi over 2, or you can write it as follows, right? I times pi over 2 plus 2 pi m. Okay? Makes sense? M is an integer in this case. So that will be the answer. So this is my I to the I, which is written as an exponential. Let's go ahead and rewrite this. I want to write the I first. E to the power I times, what is the next part? I took this I to the front, and now I have pi over 2. I want to write that next, plus 2 pi m, and then that is multiplied by e to the power negative pi over 2 plus 2 pi k. Make sense? This is I to the I to the I. Awesome. Okay, great. So the question was asking for what is theta. And we said that, okay, I to the I is e to the I theta. So your theta is this one. You like it? Okay. Don't worry, we're going to simplify this. But that will be the answer. That will be the solution, the general solution to this problem. So let's go ahead and take a look at some particular values. Let's try to simplify this a little bit. And then we're going to check Wolfram alpha and also our answer in a different way or in a different form. So that's theta. So the solution to this equation is pi over 2 plus 2 pi m multiplied by e to the power negative pi over 2 plus 2 pi k. Make sense? Okay, that will be our theta. And guess what? This is real. It's kind of hard to believe, right? Really? Yes, it is real. Now, let's simplify this a little bit by assuming that, or just we can take it, right? Suppose m and k are both 0. What would happen in that case? Well, in that case, we're going to have something much, much nicer. Theta then can be written as pi over 2 times e to the power negative pi over 2. Isn't that cool? That will be one of the solutions. But of course, the general solution is better, but this is still going to work. Make sense? Now let's go ahead and check two more things. One of them being the answer from Wolfram alpha. So pay attention to this, make a screenshot, take a good picture, and we'll look at something else. Okay? Now, Wolfram alpha gives us the following as our solution. Our finding was what? Do you remember? Theta, by the way, this is theta, right? Wait a minute, though, this is not theta, because I was looking for theta, and this should be theta, right? It's e to the I theta, because this is not real, obviously, right? Or this would be theta. So pay attention to that value, because what you're about to see next is going to be, ta-da, the same thing. Exactly, that's my theta in the simplest form, pi over 2 multiplied by e to the power negative pi over 2. And this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.